Right. Maybe we start and everyone will join, catch up, because it's 1 hour long. So, all right. You can see a code over here in the screen. Can you guess which programming language it is? So if I run it over here, will it run? So that would be the next question. I mean, yeah, that's the only code. I don't have anything else. I'll just click on this play button. It might, right? Okay, so let's see if it works. I mean, it might fail, but looks like it worked. Interestingly enough, it's a Java code. Can you believe it? It's the latest one, 23rd. So, okay, next question would be, I hope you used Java in your previous, are you a Java developer? That would be the question. If not, then we'll talk. I'll try to convince something else. Are you, okay. How about you? Okay. So for you, this is probably not Java, right? How about you? Okay, okay. So this is basically modern Java. We can do. It become this much small. So if you want to write a main method, you can start just open a file. You can just type the void main, and you can start coding. So that's simple it is. I'm going to in depth, but before let me start the presentation basically. Okay. So today's presentation, basically, I will try to convince you that the Java you saw 10 years back, it's not that Java anymore. It's much modern and new programming language. So you'll love it, hopefully. Can I ask, what's your programming background? Which programming language do you use now? Ruby. Okay, Ruby is much better, obviously. But yeah, Java is getting there, hopefully. All right. So there's a stereotype with Java associated with that. Like you say, you worked with 10 years back. So I was talking to a guy a year or two back. We were in the same flight. So he used to use Java like 15 years back. So he was asking, Java is still relevant? Do you guys you still use Java? So he has some sort of memory that Java is like, complex, verbose, you have to type a lot to accomplish certain things, right? So I just wanted to break those stereotypes today. And I'll show you what are the modern things available in latest Java. So that's the whole point. I'll give you some overview. I'll probably not go in depth in many features, but I'll show you a lot of features, what we can achieve with this latest Java. And what are the syntax look like, how shorter, how concise are they are. So that's the whole goal. All right, moving on. We have a lot of new features. One of them I just showed you earlier. So I'll start with the main method because I used to teach at a university for 2 years. So I used to teach them Java. And whenever I start writing the first program, Hello World program, basically I have to do this sort of, dance. Basically, you have to write public static void main, and then if you want to write something, let's say print ln, you have to type a whole string. And then why they used to ask a lot of questions, right? Why there is a public, what does it even mean? But for a fresh student who doesn't have the programming background, these are challenging questions. You can answer them, but it's difficult to, you can explain them, but they will not get it. Because this comes later. So from that experience, it was it was difficult to convince a fresher. So it's been that way for like 30 years. So they have recently thought about it and sort of decided to remove that barrier. So we probably, to start a Hello World program, we probably don't need all of this ceremonial stuff. We can remove all of them. And we can just write something like that. So we'll open a file, Java file, and we can start coding immediately. So we don't even need the class definition as well. So you can just open a file like I showed you earlier. Maybe I don't need to. Over here, so you can see in the IDE, I'm using IntelliJ IDEA. That's the IDE I use usually, but you can choose any IDE. So over here, I have just opened a file called CDF, and then I start writing. And you see over here, I don't have anything. Can you see my screen? I mean, not. How can I share the full screen, by the way? It went. I want to show my IDE. IDE is gone. Not appearing here. Yeah, but it's only showing the presentation, though. I have to. Okay. Oh, okay. So I have to switch up. Switch. Okay, understood. So yeah, so that's the file I have. As you can see over here, I don't have anything. It's a simple Java file, and I started typing void main println, and it basically start working. So that's it. I mean, I think this is going to be super easier for the beginners. You don't have to explain a lot. You can declare variable. You can print things. Right. You can do all sort of things over here, and you don't have to do anything else. So that's a super refreshing. Personally, I feel like if I want to teach a student who has no programming background, I can just give him or her a IDE, and we can just start learning. So that's a new. That's one of the new things that Java added, and I am super fan of it. All right. So moving on, maybe I'll keep on showing the code than the slides. So let me open a class over here. So let's say I have this class over here, conference attendee, right? It's a. Can you see the class, right? Or should I increase the font more? Yeah. Okay. Okay, so let's say we have a class over here, class definition. It's just holding a few items like the name and email, and we want to transfer this. I mean, we want to use this as an object in various places. We could put in a list. We can put in a set, right? We can pass from one method to another, right? So, but to achieve all of those things, you see, I have added a lot of ceremony over here. I need to add getters, which is accessor methods name, email, and then if we want to make it immutable, we have to add final keyword over here, and then you have to implement those hash code equals, and also if you want to implement toString, you have to do a lot of work over here. For example, if I want to add toString method over here, I'll do this. But as you can see, it's like around 41 lines of code to achieve a simple things. Basically, it's a carrier. It's a holder object that we have two value in it. And to achieve that, basically, although the IDE is generating all of those things, but still you have to carry all of those things, right, with your source control. So it's sort of noise. So Java 16 came up with a new idea called record class. If we need some sort of data carrier object, what we can do is we can transform this into this. Let me show you. And we can remove all of this. And I don't need this as well. So that's all. Basically, we'll instead of a class, we will define a keyword called record, and we'll write the field like this inside the parenthesis, and that's it. All the things we had earlier are available with this, and we can just define it and we can use it. This is called record. You need that curly braces. That's still because you can write a constructor over here if you want to. If you want to add, yeah, that's kind of required. If you remove that, you will get a syntax error. So it will not work, but we still need to have this syntax. So yeah. And these are by default immutable. So if you define once, you cannot change them. And let me show you how can I use them, right? So let me remove this, maybe this one, so that I can write main method over here. So as you can see, I have defined a list of conference attendees, Bazlur at something.com. So I have defined over here list of attendees, right? And if I want to print them, automatically toString are already there. So I can just run it over here. I don't have to do anything. It's toString is over here already. And if I want to access the content of it, let's say attendee get first name. I can just get the name like this. So there is an accessor method already there. So we don't have to write all of those things. So it's so concise. I mean, earlier we had to write like 40 lines of code. Now we can just write one line. That's so much good, right? So much better. Because nowadays when we write a lot of web applications, right, we have to use a lot of data carrier object. We call data transfer object. They don't do much, just carry data from one service to another service. And to do that, previously we had to write a lot of ceremonial code. Now you don't have to. All the things, toString, hash code, equality, all of those things are automatically included into this. So that's another amazing features. Let's see if I can go back to my presentation. So yeah. So records are very much concise, immutable data holder, and you get all of them in one go. So I have just added another slide over here. If you want to add a constructor inside it, you can do as well. For example, if you need some sort of validation, you can add. As you can see in the constructor, it doesn't have a method-like structure. You don't have to pass anything. It's called compact constructor. You just write it and you start the curly brace. And if you need to write certain code over there, you can just immediately start writing your code. So less ceremonial. All right. So here's some characteristics I already shared with you. But if you're gonna get a quick look, so basically ideal for since they are all immutable, you can use them as a type safe manner. So you don't have to make sure they are thread safe. They are automatically thread safe. All right. So next one that I'm going to share with you called control inheritance with C class. Have you heard of C class? Some of other programming languages has it. For example, Kotlin has it. I don't know about C#, but Scala has it. How about Ruby? Does Ruby has C type? Okay. So the idea is our inheritance structure in Java was some sort of open inheritance. Let's say, maybe I can show you an example quickly. I should have an example over here. Yes. Um, so let's say I have a transaction processor over here, right? Let me know if you need to increase the font a bit. So it's a simple method. It's a transaction processor. It's process transaction. It takes an type which is called financial transaction, and it's an interface basically. Um, so it's an interface. It doesn't have the implementation, and I mean it has certain methods defined. So to be basically any subtype of this financial transaction, we can pass through that method. So that's the kind of open inheritance we have. Now let's say as a library developer, I want to restrict it to a certain number of implementation, and all the implementation I'm going to provide as a library developer. But as a user, I want to control that you are not able to implement on your own implementation. Let's say I have a few over here. Let's say I have bond transactions, stock transactions, and a few others. So I want to limit this only to this sort of transactions. The problem is, as a earlier before, okay, sorry. So okay, so it's basically a record which implements the interface I'm talking, which is financial transaction. Record can implement interface as well. It's like traditional class, it's just shorter. But there is certain distinction between traditional class. For example, in record, all methods are basically a accessor type. You cannot modify because by default they are all final class. Anyway, so now as a user of that library, I might be able to implement that interface and pass something to that method, right? I mean, it's open inheritance. There is no way to restrict that. So until earlier Java version, I think until 16 it was like that. But later, after 16 or 17, I don't know exactly which version, but probably after 16 or 17, they introduced a new concept called seal type. So basically, what it does is, over here, this interface I can define as a sealed interface. It can be interface, it can be class, doesn't really matter. And then I can allow some sort of permits. So let's say I have three implementation that I want to share as a library developer. I can write permits, for example, all these three. Stock transaction, bond transaction, crypto transactions. Now, let's say I have a new, I'll increase the font, don't worry. Let's say I have a new, type over here. It's basically Dogecoin transaction, and it doesn't, the permit doesn't include this. So if I now, try to implement, it says you cannot do that. What it says is Dogecoin transaction is not allowed in this sealed hierarchy. So it's a closed inheritance. You are not able to do that. And if you try it, it will fail immediately in the compile time. So that's the that's the kind of things we have now, and it's super useful personally. For example, in Java we have a string class, right? In a string class we have a everything of any sort of a string type is compact into one class. It's a final class. We cannot inherit them because of security. It is not allowed. But everything inside the one string class, right? What if we had this closed hierarchy, which is seal type, then we could have a few type of string. It could be UTF-8, it could be UTF-16, a different set of implementation. But again, as a developer, I am not allowed to sort of do experiment with it. but at the same time I can use them, right? So that's the new stuff, and I personally liked it. As if you want to develop a library, it's super useful for you. All right, moving on. Okay, so I'm gonna go a bit quick now because I already spent quite some time on the first two things, but there are a few more stuff there. So yeah, I mean it's an example basically what I have showed you. I can basically show you over here. Um, there's a class over here, is a class hierarchy that I defined over here. So basically, I wanted to make an expression evaluator. So over here, I have an interface, right? Expression, and it has certain permits, and I have a few implementations, basically. And that's it. It doesn't have any all of those things. So it's super compact. It's the same thing. I just put in one place so that you can see in a one go. You can obviously once, for example, this constant expression, right? It's a final class over here, and it implements the interface expression. But later, let's say, if you want to write another class that would extend constant expression, and you don't want to make it a final, you can use a non-sealed keyword. For example, let's say class x extend constant expression. So you can make it a non-sealed, something like that. Probably, let's see. OK, so I made it final. That's why it's complaining. OK. So if I make something, if I make that one is non-sealed, then I can basically extend it. So that's the idea. So there is two type of hierarchy. Some of them you can make it sealed. Some of them you can make it non-sealed. So that's the idea. All right, moving on. So from that two things, which is basically closed hierarchy and record, there's a new concept emerging called data-oriented programming. So we heard of functional programming, object-oriented programming. They have their own cases, but there's a new type of programming paradigm is emerging, which is called data-oriented programming. The idea is it will model your data immutably and transparently. Basically, the idea is it will travel data from one place to another, and just data, whole data, nothing else. So there is a new concept. It's still emerging, and if you Google it, you will find some articles. It's not fully sort of immersed. It's an emerging idea, basically, emerging paradigm. People are sharing ideas based on these two things, which is basically records and cell types. And there is another concept I'm going to share in a minute, which is called pattern matching. That's so super useful. Now that we have defined data, and they're immutable, transparent, they're sealed, closed hierarchy, how do I do operation on it? So that's where pattern matching comes, right? So I'm going to show you pattern matching now. So in Java, pattern matching comes gradually. It started with the smaller stuff. For example, it started with something like that. I mean, have you seen this pattern in many languages? Let's say if x instance of a string, then you can safely cast it and then use it, right? X can be any type of object. I mean, we know it's a string, but why do I have to cast it again? It's another ceremonial stuff. So with this pattern matching, we can do something like that. We don't have to basically cast it. You can just define a variable at the right side, and you can use it, basically. So that's the first state of pattern matching came into Java. And gradually on top of it, we have built much interesting stuff, which is I'm going to show you in a minute. So for example, you can do much more interesting stuff. For example, if x is an instance of string and it has length more than 3, you can write in one expression. I'll do something else, I'll do something else, basically. So yeah, we can do case statement as well, case expression. If x is string, and then when string is greater than 3, I'll do something else. I mean, we can write many case statement as we want. And obviously, there will be a default case as well, because with this pattern, we cannot make sure it's an exhaustive. So we can keep writing things like that. So that's the glimpse of pattern matching. On top of that, we have a various way of expressing this. For example, let's say it's an object value came from somewhere, and then we want to see if it's a null, then obviously this is adding, and null is added later because people are complaining. We still sort of deal with this null pointer null pointer exceptions. I mean, in C# it's called null reference exception. Some other programming languages, I think pretty much all object-oriented programming has this issue. Some programming languages basically solved it, but Java hasn't yet. So we have to deal with that. And now you can pretty much do a lot of interesting things. So over here you can see I written a thing called str. This is a preview feature of string template. It's not available to Java yet. So Java is working to incorporate string template as well. It's some sort of a string interpolation, but much better in a way in terms of security. For example, we know string interpolation is the source where we can do all sort of SQL injection, right? In some other programming languages, it's not safe, but it's much easier and interesting. But Java is trying to avoid that, so they are trying to work in a better way so that this integrity and security are better, but they're trying. It's not available yet. I added this code when I was experimenting. But the idea is, let's focus on the case pattern matching. So we can sort of, do all types of checking over here. For example, if it's a specific type, we'll do certain things. And as you can see over here in the last case, if it is even a wrapped inside another class, we can also match that. For example, in the bottom we have a class called a wrapper, which is generic, but the object we are passing, it could be wrapper of a string or wrapper of something. I don't know, but something. And we pass it. Over here, you can see we define var. So the local type inference is also here available, basically. Have you heard of local type inference? So like the keyword var. So Java has that. Basically, inside a method, if you have some variables, you can, instead of typing all of them, all the type, you can just write var, and then you can define your stuff. So that's another interesting feature. I'm not sure why some people are not fan of var, but some people are. I'm one of them. So I like using var, but some people doesn't. Anyway, so moving on. So now let's say we have something called, we can combine these two. We learned records, we learned seal class, and we can combine all of those things and use them in a pattern matching. For example, as you can see, we have an interface called option, and it permits only two class, two types, which is sum and none, and that's it, nothing else. And if you want to sort of extract value from it, we can use this kind of pattern matching. As you can see, we have only two cases over here, nothing else, because it's already exhaustive. From the hierarchy, we know that the option can have only two types, right? Sum and none. There's no other possibility. So in this pattern matching, we can just write two cases. That's all. And as you can see, you can even evaluate the value and return it from a method. So previously, Swiss didn't support as a you couldn't write them as an expression. Now you can, and you can return it from a method, or you can put in a variable as well. So yeah, and the one interesting thing you have seen over here in the first case, you see I have used the underscore. Have you noticed? Basically, if it is a none, we don't have anything, right? We don't have to operate any value. So we can just use unnamed variable. We don't need it, so we will just replace with the underscore. So that's a conciseness. And then in the later over here, we used something called record deconstruction. So as you can see, inside the bracket, we have used the verb value. So we can directly use the value from here. We don't have to define the, first of all, the type and then a variable. From that variable, we don't have to, access the value from that, right? We can directly use that value from here. It's called record deconstruction, and deconstruction is also available in this pattern matching expression. So these are some of the new stuff. Maybe I can give you 1 minute to process this. All right, moving on, I have a few more stuff to show. So the idea is, we combine all of this, right? So there's a thing called algebraic data type. We can combine all of those things. For example, over here, I know it's a little small to see, but I can basically read. So in the earlier slides, I showed you a expression evaluator, right? So I have basically wrote that expression evaluator over here. So now this is basically a 19 lines of code, but if you do it traditionally, previously, without using this pattern matching and seal class records, it would take around 60 lines of codes. So compare 60 line and 19 line. It's much more concise. You can't tell this is verbose, right? If it was 60 line, you could say that, you could argue that this is a verbose programming language. Now you should not. What's your opinion? What do you think? Did we dispel the myth? Did we dispel the stereotype? All right. So there are so many other features going on. This is called Project Ember. So many features, and many of them are basically already shipped, and many of them are in a preview state. So there is a concept in Java called preview state, because nowadays Java is released every 6 months. So they are working on a feature, and it's ready but not yet fully ready to release. So they will ship it under a thing called preview. So as a developer, you can experiment it, perhaps use it, but you have to use an additional flag. So basically, it's a warning mechanism. This is not shipped fully, but it's available. You can use it, experiment it, and provide feedback. So some of the features are under preview, and some of them are already shipped. So as you can see, list is really long. A lot of interesting things are happening. Yeah. So for example, there is a thing called module import declaration. In Java source code, you will see that we have to define a lot of import statement, right? And if the class file is longer, then import statement is also longer. For example, if you open it, you will see import statement only, and then you have to scroll down. So the module import declaration it's still under preview. So the idea is, if Java is now is a modular. They have separated all the modules into so they separate code into different modular basically. So let's say you have a imported SQL module, and you can just declare SQL import module SQL, and all the things are imported automatically. So you don't have to write like 10 statement, 10 import statement. That's something coming. But if you want to experiment, you can definitely do that. So moving on, like I showed you earlier, there is a thing called unnamed variable. So it's a complex hierarchy, right? We have a shield interface called interaction. It permits comments like share. And if we have a, let's say, method called process interaction, and we have a pattern matching over here, maybe we are not interested all of them, right? Some of them we are interested in. For example, the second case, in the comment, we are interested in only the content, not the two other. So you can just put underscore. That will, make your code smaller. You can read in by one go. So that's called, unnamed variable. But I feel like it's much concise now. So you can use them in many places. All right. This is a small feature. I wouldn't say this is an enhancement, rather than it was some sort of inconvenience. They fixed it, and personally, I liked it a lot. But still, let me show you what it is. So let's say we have a class called big integer in Java, and you want to extend it, right? And you want to write a positive in big integer, but the requirement was you have to call this super right before the first line of the constructor. It's some sort of inconvenience. You have to do it. It's a restriction was put in place. So now that, let's say, super will do some work, right? In the previous constructor, I mean, super class constructor, it has a lot of work. So they will do a lot of work already, and then later you are doing, if it's not positive, then throw in exceptions. So all of your work basically gone waste. So they fixed it. It's a convenience now. So you can do call super later, basically. So you do also all your validation before, and then you can call super. It was inconvenience. I feel like it's a fix, small feature, but personally I like it a lot. If you override a constructor, sorry, I probably in constructor, probably not. Yeah, so basically, if you have a constructor in the superclass that takes argument, if you extend, I mean, if that constructor do certain works based on the arguments you provide while you are, instantiating the object, it's a sort of requirement. You have to. Okay. All right. So let's moving on. I'll go basically swiftly now on, because these are basically features that are available you can use if you want to. So this is called Vector API. The idea is modern hardware basically support something called SIMD, basically single instruction, multiple data. So let's say you have a for loop, right? You want to do some processing. So you can do a scalar operation, like let's say multiplication, addition. You can do two data at a time, right? Usually that's how we do. But some hardware, modern hardware, support one single instruction but support multiple data. For example, you can do multiplication of 8 data at once. So if you have a single data, there is a two type operation now, right? Single operation and vector operation. Let's say vector operation takes multiple data. So you can go 8 times faster in some processing. So that's available. This is called Vector API. And you can take some advantage of those. So here's some code. For example, this is a scalar operation. I mean, you want to, let's say, addition using a loop. And basically, you have a 2 array. And you can put the value into another array, right? It's a scalar operation. But if your hardware basically support the SIMD, you can go this. It's a bit involved, but you can go faster this way. although you have to write a lot, but you can achieve result faster. So in this way, we can go like 8 times faster. So that's available. You can search Factor API. All right. Should I move or you wanna? So basically, there's some APIs defined. So basically, it's based on that you can see how many operations at a time you can do on that particular hardware. Yeah. So moving on, there is another thing called foreign factored memory API. That's super useful. Do you know why Python is so much popular nowadays? Because all the data science related work are done on Python. And their massive libraries are available written in C and C++, right? And Python sort of, use them directly from easily. Basically, they have interoperability. They can call a C function, C++ function easily. And Java has this through JNI, but JNI was it was a nightmare basically. As a developer, I wouldn't recommend using JNI. So there are massive amount of libraries written in those languages, those native languages, C, C++, and we were not taking advantage of those things. I mean, there was a way JNI, but I can show you how difficult it is. So let's say over here, I want to do a quick sort using the native library. I mean, it's available probably in the in this one of the library sections. So let's say this is a class. I want to load a library and then do some native operations using JNI. So I have to do a multiple steps basically. I don't know if you can see it, but I can explain. So basically, you have to first compile the class, and then you have to generate a header. And then using another compilation, you have to compile the native library, and then you can load this. Basically, you have to go through multiple steps. And something changed in the library or in your code, you have to do the whole processing again, whole things again. It's a super buggy, tricky, and a place for memory crash and also all sort of things. So with the foreign memory and function, you don't have to do all those exercise. Basically, I can show you the code. It's all. It's difficult, I know, but I'll share the slide with all of you. So the idea is you don't have to go through anywhere. There are few API available. For example, all these API now available. All are written in Java, and you can just use them from your comfort. So bottom line of all of this is basically with this foreign memory, foreign function memory API, you can access native library. You can allocate memory outside of your heap, and you can sort of allocate a huge chunk of heap, and all of them are controlled from your Java. So basically, you don't have to jump hoop. So that's the facility. So now, if you are a data scientist, or I mean, if you're a developer of, let's say, data scientist-related library, or machine learning, AI, all those things, you can take advantage of those native library available, and you can write a wrapper around it on Java and ship it, and people will love it. All right. So I'm not going to spend a lot of time on over here. I'll share with you. But the most fascinating stuff in the whole recent Java advancement, which is called virtual threads. So Java has a concurrency from day one. The problem with the use of the need of concurrency evolved like 1995 to 2024 a lot, right? So we have a more concurrent stuff going on applications, but in Java, the threading model was some sort of like one-to-one mapping with the operating system threads. And operating system thread has a limitation. It based on hardware, based on operating system, it's around, let's say, 2,000, 4,000, 10,000, right? But the problem with those limitations, even though if you want to use all of them, if you employ all of them, there will be a context switching overhead, right? And they all take like a big chunk of memory. So if you add too much thread, there is a potential your application will slow down gradually. But if you use less, then less concurrency going on. So they have solved a new idea, solved it with a new idea called virtual threads. It's a more of a user-defined thread, user mode thread. So the idea is there will be an operating system thread, and on top of that there will be a we call platform thread or traditional thread. There will be one-one mapping with them, but all with platform thread there will be a virtual thread, and the relationship is many to one basically. So potentially you can create millions of virtual threads with these new things. So I have a short demo for you that will give you an idea what we can achieve. So let's say, okay, I have to go back from here. So look at this code. Basically, it's a simple web application, web server. It doesn't do a lot of things. It's just open a server socket and listen if any client join in. So if anything sent from the client, let's say any text, it will just uppercase and resend back to the clients. So that's the only thing it can do. So let's run it. And I have a terminal over here. So I'm going to do telnet. I'm not sure if you can see it, but I will try to increase the font. So over here, it's connected with the port 888. And if I send hello, it just sends back. It's just ping back the hello in the uppercase. But the problem is I'm only connected with this server with one terminal. And if I go to another terminal and try the same thing, and if I send, it doesn't return anything. Because the server application is single-threaded. Inherently, one thread is doing connected with the another client. And unless we close that, it will not respond. So that's a difficulty with a single-threaded application. So we can solve this problem simply by creating a thread whenever a new client basically joins. So there is a way of doing that. Thread of platform.start. Okay. So writing this one line, we are making in multi-threaded programming. So let me run it again. Now, if I connect, as you can see, it returned. Sorry. If I try it, it will definitely send back, right? So two multiple clients can work at the same times. Now, let's say we need a huge amount of concurrency. What if 10,000 clients, sort of, try to connect to this server? What would happen? So over here, I'm basically I wrote in simulation. It's called DDoS attack. I'm sending 10,000 requests at once to that particular server. So let's see what happens. So it's creating, and after a while, you see, I can read it for you. Unable to create native threads, possibly out of memory, or there is another things. Basically, we ran out of the thread. We ran out of the native thread. We don't have ability to create 10,000 native thread over here. So that's a problem, right? But we want to achieve that level of concurrency. So, okay. So what we can do is we can just change one line over here. Over here, instead of using platform threads, I'm going to use of virtual. So now I'm not going to use the platform, the traditional threads, rather the new virtual kind of threads. And I'm going to rerun this. So now I'm going to run the same DDoS attack again. And let's see if it can tolerate this many requests. As you can see, it sent and finished. Basically, nothing happened. Over here, it didn't show any sort of error. I mean, it handles basically 10,000 requests at a time. So virtual threads, how it works, I'm going to go a bit details. So what happens is it creates a new kind of Java construct. It's called that construct act like virtual thread, but over there we have something called fork join pool. So it's a thread pool, and thread pool used the number of core available on the machine. Let's say we have 10 core available on the machine, so it will create 10 thread, and it will pull them. So and if we have like millions of virtual threads, they will schedule them. So we have a new scheduler in place in the Java. It's not a operating system scheduler. It's more of a Java construct. So if we create a virtual threads, it will immediately get created, and it will stay in the heap. But let's say we have many of them, and the fork join pool will keep on scheduling them. We'll take one, and it will work for a few moments. And there is a thing called, the problem with traditional threads, there is a called blocking operation, right? So let's say if we have a blocking operation, let's say we have a limited number of threads, and we have a few blocking operations. And traditionally, what happens? If a method calls a blocking operation and some thread is operating on it, this thread is blocked. We have a limited number of threads, and we are basically wasting one thread for a few milliseconds or for few seconds. And with those times, that particular thread doesn't do anything, right? It just staying there doing nothing. That's a scarcity. With the new virtual threads, what it can do is it's executing something, and it sees some blocking operation. It can yield itself from the scheduler and wait somewhere in the heap, and the scheduler gets free, and it can pick another virtual threads. That way, it keep on going. So, and since it's a Java construct, we can create millions of them pretty fast. I mean, I can go in depth but time doesn't permit. But yeah, that's a new construct available in Java. So hopefully in future, everything is going to go in every blocking operation. I mean, we have a reactive stack as well, but people will eventually start using virtual threads instead of reactive. That's the kind of future I'm looking. So now, if we want to, let's say, write a super IO-driven applications, we don't have to worry. OK, so I don't have much time left. So I'm going to quickly show you a few things. There is another thing called structured concurrency, but time doesn't permit. But I can quickly give you an idea. Let's say I have parallelly calling two methods. Both of them are dependent from one another. And if one fails, then basically whole result is failed. And we want to sort of get away quickly from that whole methods, right? So with the traditional concurrency, there is no correlation between two threads. Basically, they are independent. So if one method is failed, and the other, let's say taking a 300 milliseconds, and it will still continue, even though the other one failed. So since there is no correlations, there is no communications, and they sort of act concurrently, even though one method failed, we are still waiting for other method. Although it doesn't make sense, we can quickly, interrupt that method because other one failed. With the structured concurrency, it gives us a framework that, if there is some sort of dependency in between, if one method fails, we can define that contract, define that policy. If one method fails, we can quickly come back. We can interrupt the other one. Or we can write, let's say I'm calling 5 child tasks. If one of them succeeded, I want to go back. I don't care about the other 4, and we can interrupt 4 of them. So I'm not going to spend a lot of time on that. So we can sort of come up with a few different policies with this structure concurrency. So that's the new stuff. All right. So that's basically all of the content I wanted to show you. If you have any questions for me. So this is a little bit about me. I'm writing 2 books. One is on O'Reilly, basically called Modern Concurrency. I'm going to write all of the things called virtual thread, structure concurrency, all the modern stuff. It's mostly based on concurrency. I have written a couple of pages, so if you have O'Reilly subscriptions, you can definitely read it now even. And I'm also writing another book on a lean pub. This is basically all the newer stuff that I have already showed you. So I am about 45% finished, and I'm still writing. It's an evolving book. So if you want to get it, you can get it now. Even you will also get updates. But these are 2 work currently I'm doing. Thank you. And yeah, we have like 2 minutes, 1 minute. So if you have any questions for me.
I wanted to ask about the sealed classes. Why would you need to restrict the? Because I didn't get it. Why would you like to restrict the inheritance?
So let's say, let me give you an example of a string, right? As a string is complicated object, and there's a many